5L, the adaptive immune response, also known as the acquired immune response. Unlike the other innate responses that one is born with, the adaptive immune response requires programming whenever a new pathogen enters the body before a defense can be applied. As a result, the adaptive response can take days to program, while the innate immune response can occur immediately. The adaptive immune response can be split into two sections. First is the humoral immunity, as it takes part in the humors or fluid portions of the body, like the plasma, blood, interstitial fluid between cells, and the lymph. More commonly, it's called the antibody immunity. The second immunity is called cellular immunity, or cell-to-cell immunity, as it requires that two cells directly come into contact to act in destroying the pathogen. Humoral immunity involves B cells in blood, interstitial fluid, or lymph looking for foreign antigens. They do so by testing the antibodies they have on their cell surfaces with all the antigens that they encounter. In this picture, the B cell only has 3 antibodies showing, but an average B cell will have 10,000 unique antibodies per cell. With the total B cells in a human body, that results in 2 to 10 billion antibodies in total, circulating around looking for a matching foreign antigen. Recall, an antigen is anything that results in an immune response by an organism. Once a foreign antigen is detected, the B cell will present it to a second white blood cell called a T helper cell. The T helper cell will help to confirm that the antigen is in fact foreign. Once both the B cell and the T helper cell verifies the foreign particle, which may be a bacteria, virus, protein, etc., the B cell will divide into a plasma cell, also called an effector cell, and a memory B cell. The plasma cell will keep dividing to make more plasma cells and more memory cells, but they will not also generate and eject antibodies that are specific to the antigens at a rate of thousands per second. The antibodies coat the antigens, preventing them from being used as keys to enter the cells, and due to the clumping nature of the antibodies, once bound to the antigens, the pathogen is also prohibited from moving around. The antibodies coating the pathogens labels them to be eaten by the phagocytic macrophages. Once a pathogen has been defeated, the plasma cells will be recycled, but memory cells remain, and some are viable for up to the remainder of your lifetime. This allows your antibody immune response to skip the first few steps next time you're exposed to the same pathogen. Your memory B cells will immediately form plasma cells producing and ejecting thousands of antibodies per second to help defeat the second infection in a very short amount of time. This is why most people do not experience a second case of the same chickenpox, measles, cold, or flu virus. Cell-to-cell immunity is another adaptive response that targets a specific target. When phagocytic cells ingest pathogens, they often will present some of the undigested foreign material on their surfaces. This could include antigens. The phagocytic cells, like macrophages, will present themselves to the T helper cells. And if the T helper cell confirms that the particles are that of a foreign pathogen, it may become activated, turning into an activated T cell, also known as a cytotoxic T cell or killer T cell. Typically, our bodies have tolerance for our own cells. However, when a virus enters a host cell, it will often leave its surface protein antigens on the surface of the host cell. Killer T cells will recognize these foreign antigens on the surface of our infected host cells and bind to them, killing them using chemical cytotoxins and perforins to lyse them.